Bismillah ar-Rahman ar-Rahim. Allahumma salli ala Sayyidina Muhammadin wa ala alihi wa sahbihi wa sallim tasliman kathira. ربنا زدنا علما ربنا زدنا علما وفهما وعبدا كاملا ربنا يسر ولا تعسر ولا حول ولا قوة إلا بالله العلي العظيم. Assalamu alaikum everybody. I welcome you to the session 2 of the study circle here online on Seeker's Guidance regarding understanding the fiqh and the science of establishing the lunar months, and hence how it affects the establishment of the first day of Ramadan, and the two Eids, and obviously the Hajj. Inshallah, the first session of the video, the audio, and the printed notes has been of some assistance to you to understand the fiqh and the usuli principles that are relevant to the matters of crescent sighting. And here in lesson 2, inshallah, we are entering into a discussion surrounding a reasonably complex set of issues, and that is the science of the lunar observational astronomy. I wanted to make a quick point, firstly, that the fiqh and the usuli matters that we have spoken about and we will continue to speak about are not theoretical modern ideas, but these are in fact established very firmly in our classical texts and based on our four madhabs, and I'm simply transmitting that information with additional commentary for us to understand what those rulings and principles in fact mean. Similarly, when we are speaking about the science here, we are specifically speaking about the facts that actually surround the matters of science in terms of the crescent sighting. We are not talking about theory. We certainly are not going to be talking about the philosophical theories that sometimes have crept into the discussion surrounding crescent sighting affecting our lunar calendar. I think the scientific understanding is so important because it helps us to firstly make sense of many of the fiqh rules that in fact are present, and secondly, it helps us to be accurate so that we can eliminate the numerous errors that tend to creep every single year, which is an unfortunate saga for us as Muslims around the world. And may Allah subhanahu wa ta'ala give us tawfiq in getting matters right of our Sharia. So today we will speak about firstly the limitations surrounding calculation because of our fiqh. We have actually spoken about that in lesson 1, but we will summarize that from a perspective of calculation and how scientific data and calculation obviously coming together and how they are limited because of our fiqh. I want to make a quick point again here is that when we're speaking of scientific data, it is obviously what we speak of in terms of calculation, but we need to understand that this is not about predetermination. This is about using the data to increase the accuracy of what happens at the time of sighting. That is the critical difference between those people who might rely on a predetermined basis of calculation and those who are actually doing the moon sighting and use scientific data to provide a very accurate ability to know whether the moon can be sighted or cannot be sighted, or in fact when a claim is made and whether the evidence is contrary to the claim made, as we had spoken about in session 2. So that will be the fiqh discussions and more summarizing from lesson 1. And secondly, we will also speak about the natural limitations to calculations. There are certain things in nature, how the moon behaves. The entire lunar behavior has many limitations that in fact that we do not know exactly when the crescent is sightable from the earth. And these are natural limitations that is over and beyond the human capacity, and we need to address that and accept that in fact a predetermined calculation is simply an incorrect way to try and understand something which is able to be established through in fact sighting. I want to also make a point here that in fact those people, by far and large, not all people, but those people who do rely on predetermined calendars and calculation, unfortunately do not rely on the scientific data because their data is so inaccurate. For example, there are many organizations and communities which rely on, say for example, the new moon data rather than the crescent in suggesting or asserting which day of the month, which will be the first day of the month of any of the lunar months. And this is not relying on scientific data at all, although there is this kind of a assertion and a claim that they are relying on scientific data. In my personal experience, and I happen to be on the executive, I'm an executive member of the Islamic Crescent Observations Project, which is a global organization and a network of astronomy experts as well as Sharia scholars who understand the matters of astronomy, that in fact most people who do moon sighting actually use scientific data more accurately than those people who rely on the so-called predetermined calculation. We will also talk about the beneficial use of scientific data, that we do not have this polarized idea that somehow scientific data is against the Sharia, that in fact the scientific data is purely the means by which we are able to have accuracy in our physical sighting that we would do on a monthly basis. The first of the things we will look at is to look at a summarization of the matters surrounding the fiqh, and what are some of the things we have already spoken about and which are then relevant to the matters of calculation itself. So firstly, let's have a quick review of what we have looked at in session 1. The first one was that the principle of certainty requires us to act upon certainty. And so we need to firstly know that we have to actually establish certainty, and a pre-calculation in no way provides any certainty. In fact, doesn't actually provide much probability of certainty at all. And in fact, the level of uncertainty is too great in the issue of sighting the moon. I will return a little later on in this session to show how, in fact, scientific data can provide a certain level of certainty, but certainly not when it comes to the earlier part of the crescent sighting in itself. And that matter will be resolved as we go along with our study here, inshallah. The second principle that is agreed upon in terms of our fiqh, and that is the principle of evidence versus witness. That in fact, facts, which are evidences, do override the claim of a witness. A witness can make a claim that he or she has sighted the moon. However, if the facts are completely different to that, then in fact the moon, for example, has in fact already set, that is below the horizon, then in fact this kind of a claim for a person to say that they have sighted the moon will in fact be rejected because of the evidence present. And third agreed upon fiqh matter, and that is the matter of causation, the matter of sabab, that all obligatory acts are caused to become obligatory upon the human being through what is called a sabab, and acting prior to the sabab coming in is in fact a invalid action. So if the moon has not been established with certainty, and if there is a wrong witnessing because facts are otherwise, then the sabab is clearly not in, and therefore fasting, for example, cannot be started because the facts are that at the moment the time for fasting has not yet started. And that is what is a sabab is, and inshallah we will look at that in some more detail as we go along. We look at further discussions surrounding the fiqh matters, because remember the linguistic side of our fiqh is very, very important, and we need to separate and differentiate between what is referred to as the new moon and also the crescent. And in fact there is a difference. There are two different phenomena that in fact exist. One being the new moon, and sometimes technically referred to as the new moon conjunction, and secondly what is referred to as the crescent. So the first thing to understand in relation to the new moon is simply that Allah subhanahu wa ta'ala has already told us that in fact the moon is a reflector. It doesn't give light by itself, as he says in the Quran, Bismillah ar-Rahman ar-Rahim, Huwa alladhi ja'ala ash-shamsa diya'a wal qamara nura. So this idea that he has made the sun a shining light, or a diya is something that actually gives light, and the moon is something which is is derived light, or light that is reflective, and so the moon itself doesn't have any light. If it doesn't reflect any light from the sun, it will not be possible to be sighted from earth. And this is a very important thing to understand. And the aspect of the new moon is that it is at a location. The moon actually goes around in an orbit and comes at a particular location every month, when all of the light then is reflected away from Earth and towards the sun. And when this actually happens at a particular time, approximately 28.4 days after its lunar cycle and approximately 29 odd days, then at this point of time it is called the new moon conjunction. It is in an alignment between the Earth and the sun, such that all of the light is reflected away from the sun, from the moon, and it cannot be sighted at all. It cannot be seen from Earth at all, and this is not what Allah subhanahu wa ta'ala has demanded for us to in fact sight, simply because it's impossible to be sighted. This in Arabic is in the lunar observational astronomy. In Arabic is called Tawlid al-Qamar. In other words, the birth of the moon. This is what we call the new moon birth, or the new moon conjunction. And this is not what Allah subhanahu wa ta'ala has asked us to refer to in relation to our lunar calendar and the establishment of the matters of Sharia. To understand this element of what is new moon and what is the crescent, what we would like to first look at is this. Is the new moon is something which is not seen. As you can see over here, it's there, but it's not seen. You probably saw that yellow circle flash there. It's there, but we can't see it. We actually can't see it. And the moon has to move at a particular distance on its orbit in order for it to, for the first time, reflect light towards the Earth. And when it does that, this is what we see. We see it as a crescent, and what is normally referred to as the waxing crescent, which is the new moon crescent. And this is referred to as Hilal or Al-Hilal, and it is the sighting of this that is required by the Sharia. And Allah subhanahu wa ta'ala tells us in the Quran about the manazil, about the appointed measures of its phases, and the waxing crescent, it in fact is one of the phases of the moon. And it's quite interesting, in this verse Allah subhanahu wa ta'ala refers to the shape of the crescent, hatta adak al-urjun al-qadim, that this is actually, it looks like an old branch of a date palm. And if you've ever seen an old branch of a date palm, it curves, it actually twists. And the word urjun comes from the root word araja, which means to actually rise up, and it shares the same root word with what we refer to as Isra wal Mi'raj. So this idea of something that actually rises, and the ta'raj is that something that twists, and the two corners rise towards a particular point, and therefore what we see is the crescent. And just to replay this for you, so that you can see that in fact the circle is always there, but we just simply can't sight it. So there is a circle which actually is present. The moon is there. It's not as if the moon actually has come and appeared from nowhere. The moon is actually there, but we can't see it because no light is reflecting upon us. And as the moon moves, we will suddenly see this crescent because of the light that actually is being reflected towards the Earth. Continuing to understand some of the linguistic matters here, and moving from the new moon, we now look at the crescent. And the crescent, referred to as the hilal, this is the shari'i sabab in order to establish fasting, the two Eids and the Hajj. That we have seen that Allah subhanahu wa ta'ala has said in the Quran, فَمَنْ شَهِدَ مِنْكُمْ الشَّهْرَ. So this idea that the shahada, the testimony of the month, must be made on something factual. We've seen the idea, the meaning of the word shahada, faman shahida, is that this testimony must be something which is factual, something that somebody knows and has seen. So sometimes the word seen may not have to be applied, because people will say that, well, shahada doesn't have to be seen. Yes, that is one of the derived meanings, but the point still exists, and that is a testimony must be made on fact, not on probabilities and possibilities, particularly when those probabilities and possibilities are not even certain. And this is the case of the formation of the crescent. And we also have seen that the meaning of the word shahr is also synonymous to the crescent, that Allah subhanahu wa ta'ala continues to refer back to this matter of the shahr, of the hilal. We've also seen from the hadith that the hadith in fact demands a sighting as the means to establish our Ramadan, etc. And that is from the word of ru'ya. What can be sighted, what can be known, and that is the crescent, not the no, the crescent cannot be calculated. So we cannot calculate this matter, and it's not referring, the ru'ya is not referring to the new moon, because the new moon can't be sighted. So to suggest that we can actually rely on the new moon data and then work and say when the new moon has formed, therefore our month has been established, well, this actually contradicts the idea of what actually could be cited, because we have just seen that the new moon in fact can't be cited. And we also know that the calculation cannot be done in relation to when in fact the crescent will be cited. We can have possibilities, but we certainly cannot have certainties. And number three, we have seen just now that the crescent is the only thing that can be cited but not in fact calculated, and this is a scientific fact. The crescent in fact forms from the 29th day, and between the 29th and the 30th day it will in fact be sighted, as per the hadith of the Prophet sallallahu alaihi wasallam. So we now move and look at some of the natural limitations that in fact exist about those things which impede our ability to sight the crescent. And things like the sun glare, what is referred to as the Danjon limit, the sun-moon separation, the lunar orbit, and the atmosphere, the atmospheric conditions itself can in fact impede or limit whether we are going to be able to sight the crescent at any particular time. And in fact, there are many other variations, and we are unable to put all those variations together because there are so many variables that in fact exist. I'm simply going to go through those which are the most common for us to understand, and probably the most important ones for us to in fact understand. It is also important to know that none of these natural factors somehow operate or exist in a vacuum on its own. They in fact obviously interact with all of the other factors. So whilst we are about to enter into discussing each one of these separately, you have to keep on understanding, keep on at the back of your mind that, say for example, the sun glare issue is highly contingent to the issues surrounding the Danjon limit. But we have to look at them individually to understand the limitations, and hopefully you are able to come to a simple understanding that the complexity of this is so great, and therefore one of the reasons why we are unable to precisely calculate, pre-calculate in fact when the crescent will in fact form. And in some of these we will in fact look together. For example, the issues of sun glare and the atmosphere, we will be looking together. And as far as the lunar orbit is concerned, we will simply make a quick few points rather than going into too many details, because there is no need for us to in fact do so. To understand what the sun glare is, if you look at the diagram that is in front of you, the sun, the yellow middle circle, and this is when the sun is halfway down the horizon. And by the way, this is not the definition of sunset in Islam. The definition of sunset is when the top part of the circle in fact goes below the horizon. But we need to look at this part when the circle, when the sun's disk is halfway down the horizon, as a matter of scientific issue, which I'll explain as we go along. Suffice to say for now is that if you see where the circle is for the sun, that's the actual sun disk. But the sun leaves behind it a major space, a circular space of sun glare. And if the moon is present in this sun glare, we are not going to be able to sight this moon. And so, just for your information, there is the moon there, and at the moment the moon is behind it. So when the moon was behind it, we are unable to sight it. So I'll quickly just go back here. Here the moon actually is in the orange sun glare circle in the sphere, but we are unable to sight it, like as the diagram shows. And this is actually, in reality, this is exactly what actually happens. However, when the crescent or the moon is present outside of this glare, we know we can sight the moon. In other words, if it's inside this glare, we actually know for a fact that we are not going to be able to sight the moon. Why? Because the glare of the sun is stronger than the glare or the reflection of the light from the moon. A simple exercise of this would be that if you take a white piece of paper, use a correction fluid, the white correction fluid, for example, make a little dot on it, so white against white, and then ask people from a distance to show where, or see if they can see where the dot is. They won't be able to. Why? Because the white surface of the paper is brighter in its luminosity than the actual dot that you have made. Similarly here, the crescent, the light coming from the crescent is too little in comparison to the sun glare itself. So when the moon is outside of this glare, as we can see there, then without a doubt we will know that in fact the moon can be sighted. And we know the boundaries, we know the limitations when the moon would be inside the glare and when the moon will be in fact outside the glare. This is well known by scientists, by astronomers, and in fact can be calculated to know when the moon is going to be inside the glare and when, generally speaking, outside the glare. However, we have a continuing problem in our world today that in fact atmospheric conditions like pollution and haze can cause a situation where the glare can in fact be expanded. So today, in today's world, we are seeing that the minimum amount of time that the moon has to lag behind sunset. In other words, if the sun is setting at 6 p.m., then the moon has to be at least setting at around about 6:40 before the probability of the sighting can be possible. This is something we know as a fact in this regard. The reason why it's 40 minutes and 45 minutes is because whilst the minimum is understood to be 40 minutes, things like pollution and haze, etc., can in fact cause the sun glare to be greater and refraction in the horizon to be greater, as the lighter gray sphere that has been shown to you suggests that sometimes that can be present and can cause difficulty in sighting. Now, we know this, and there are many times when say for example, when the moon, let me quickly write some numbers here for us to work through this together, inshallah. Say for example, let's have a look at and suggest that the sunset is at 6 p.m. at your city. In your city, the sunset is at 6 p.m. If moon set is equal to, say for example, 6:20 p.m., so in other words 20 minutes after sunset, and this is normally referred to as lag time, then the only conclusion is that moon can't be sighted. The glare is too much for us to be able to see the moon. However, if the moon set is, for example, say approximately 6:45 p.m., then we know that the crescent or the moon is possible, not certain, but possible to be sighted. So we are able to work these things out on a monthly basis and know when, in fact, the moon is within the glare and when the moon, in fact, is not in the glare. And so moving on from the discussion surrounding sun glare and atmospheric conditions, there is something also called the Danjon limit. This is a reasonably technical issue, and I want to simply summarize this by saying that this is about the laws of reflection, and there are other issues surrounding Danjon limit. The name Danjon limit is after one of the scientists, Danjon, who discovered this issue that needs to be taken into account in relation to the sightability or the visibility of the crescent from Earth. And it really is about the laws of reflection of light from the moon as viewed from the earth. And I'll draw some quick diagrams to actually explain it, but the quick point that we need to understand is that the current understanding of the Danjon limit is that in fact some of the scientists have said that in fact the minimum hours of the moon age is around about 8 hours, and the general understanding and the general agreement is that in fact it would be around about 12 hours. And I want to remind everybody that remember that when we say that the moon has to be a minimum of 8 to 12 hours before the sighting can be possible, remember this is only one of the variables. All of the other variables must in a very complex way come together to give us a better understanding of the moon behavior at any one point of time. So whilst the Danjon limit, for example, is around about 8 to 12 hours, then something called, for example, sun and moon separation can add to this matter and cause the moon to not be able to be sighted for any less than 17 hours as an age. So it's a very complex set of information that comes together, and soon we will come to a general idea that when the moon on a monthly basis, or in fact daily basis, behaves, what do we know about the moon, that if the certain criteria, the certain realities of the moon exist, whether it can be sighted or not. So looking at, quickly coming back to this idea of the Danjon limit, know that the moon is not a smooth sphere. This is not what the moon is. The moon is not a sphere. It in fact has plenty of craters and mountains and craters on its surface. So we can literally zoom in here if we want to, and say that exaggerate this diagram and say that there are in fact these mountains on the moon, and there was obviously craters as well, and mountains, etc., etc. I'm obviously exaggerating the diagram over here to make a point, and this is obviously about Danjon limits. So you can imagine if, say for example, a light ray comes from the sun and hits the mountain, just to get this more graphic, inshallah, then this light may, in fact, within the structure of the moon, the surface of the moon, it will obviously, I'm obviously exaggerating this diagram, it will actually bounce off, and reflect off its mountains, etc., to the extent where it might actually bounce off and go inside the crater like this, and it will continue to then bounce off in this crater. Now, if you were standing inside here, you will obviously see the light without a doubt. But remember, this is what we could say literally captured on the surface of the moon, and it is not reflecting towards the earth. And if it's not reflecting towards the earth, remember, al-qamru nura, the moon is a reflector. It reflects light, and if it's not going to reflect any light towards the earth, you can't see it. And because of this limitation, we know that we need approximately 8 to 12 hours from the new moon age. Oops, sorry. So 8 to 12 hours before we know that the light is coming towards the earth, which is visible to the naked eye. Now, I do want to make a point over here that there are other sciences, particularly around certain infrared and other kind of light photometric work that is done in astronomy to capture certain kinds of light that in fact has other information surrounding Danjon limits, but they really are not of any consequences to us when it comes to the issue of moon sighting. The reason being for that is that the matter for us is to actually sight based on naked eye, and those photometric kind of digitization and photography is not applicable to our sighting. So that's the second limitation. The first was the sun and moon glare, and the second was the Danjon limit. And here we are quickly looking at what is referred to as the sun-moon separation. And the sun-moon separation is, simply speaking, how much is the moon separated from the sun. And we can have the separation uh, uh, based on what is referred to as altitudinal separation. In other words, how high is the moon from the horizon, also how right or left it is from the sun, from the center of the sun itself, and also what is sometimes referred to as the elongation in a particular location of the moon in comparison to the center of the sun, from the center of the sun to the center of the moon. I don't want to go into too many details. This is a very brief program that we are running here as an online program. We in fact have a different program to actually educate people and train people with all the scientific and the fiqh matters for them to establish a proper system within their community. This is more informational for us to understand all these limitations and matters that needs to be taken into account. So I apologize if some of the matters are not explained in too many details other than in an introductory way. And inshallah, for those people who are interested in understanding these matters in more detail, that you will contact Seekers Guidance. MashaAllah, they do a great job in providing this information throughout the world. And if these information you need to understand for your community in more detail and to be trained in this matter appropriately in the fiqh of it and the science of it, I can assure you that we'll be more than happy to provide the training for that as soon as possible. Coming back to the issue of the sun and moon separation, we can see that again the sun actually is the yellow part of the sun, and you actually have the sun glare. And we will, for the purposes of understanding the sun and moon separation, know that obviously if the moon was inside the sun glare, and that again has to do with the sun and moon separation, if it was inside the sun glare, we will not be able to sight it. So the moon has to be outside the sun glare for us to sight it. However, for to make the diagram simpler, let's remove the sun glare and simply understand the issues surrounding the sun-moon separation. So the moon will be in a particular location in comparison to the sun, and we can literally throw a grid that if we know where the sun is setting, and from that point of set, and here as you can see at the midpoint of the sun, we can use that midpoint of the sun just before sunset happens and actually work out exactly where the crescent is. So visually, observationally, we can in fact work out exactly, pinpoint it, and using a ruler we can in fact measure a very basic and an approximate location of where the moon in fact would be present, so that you can cast your eye into that area and start to view for the crescent, inshallah. And here I'm not going to go into the details of how to create the ruler, etc., etc. We will speak inshallah about that in separate discussions that Allah may Allah subhanahu wa ta'ala give the opportunity for those matters to come to us. So when the sun sets, it was very important for us to be able to know where the center of the sun was, so that we know the point of set. And I want to quickly go back to that point here. As you can see, if you miss the sun going down the horizon, you will not be able to do this appropriately or accurately. You need to get to a location to be able to see the sun as it sets. And once you know where the sun has set, you can locate and pinpoint this location, and that from that point you can measure right or left of the sun depending on the dimensions and the measurements and the data of that month, because the data varies every month, and also how high the moon is, and it will tell you the location of the moon. But this location is not only about locating the moon, it's also about whether the moon can be in fact sighted because of its separation from the sun. If it's not separated enough, not enough of the crescent will be formed, or no crescent will be formed. And the more the moon is separated from the crescent, the sun, sorry, the more the crescent luminaire or the illumination of the moon is in fact present. And when that is the case, the more the separation in fact occurs, the better chances are for us to be able to sight it. And so, in summary, the natural factors that limit or hinder crescent sightability, the first is the sun glare, and it can be affected by the atmospheric conditions, and we require a lag time. In other words, the moon will have to set at least 40 to 45 minutes after sunset for the possibility of the crescent to be viewed. And generally speaking, this will occur when the moon age is around about minimum 18 hours for probable sighting, although it can be slightly less, and we will speak about the variations as we go along, inshallah. The second limitation is what is called as the Danjan limit, and the Danjan limit is based on the laws of reflection, as we had spoken about, and the minimum amount of time before probable sighting based on Danjan limit issues is around about 8 to 12 hours of the time from the new moon forming. And we also have what is referred to as the sun-moon separation, and we have spoken about this, what is called the left and right separation of the moon, which is called the azimuthal separation, and the height of the moon called the altitudinal separation, and how far the moon is from the sun, which gives what is called an elongation of the moon, in order for us to be able to see the illumination of the moon and hence the crescent. And generally speaking, this is one of the most important data, in fact, in the aspect of the sightability of the crescent. And generally speaking, the sun-moon separation, the best or the minimum time that is required is approximately 18 hours from the moon, new moon forming. So the moon age will have to be around about 18 hours before the possibility of the sighting is in fact possible. The lunar orbit. We don't have to talk much about the lunar orbit other than to briefly mention, if I can quickly draw some diagrams here for us to look at the issue of the lunar orbit. What it means is that if you can imagine that this is the sun, so we can draw the sun over here. So let's say that's the sun there. Obviously the earth, it actually obviously goes around the sun, so we will have the earth going around in orbit like that, and we will have so this is the earth, and the moon will go around the earth. And the critical point to understand is that the earth goes around the sun in a circular orbit, and the moon goes around the earth in an elliptical orbit. So this is the moon and this is the earth. And so the distance from the earth, from the sun to the earth, is equal in all directions. Approximately, it's equal in all those directions. But as we can see, for the moon, this is not the case, because at some location the earth and the moon is in fact close to each other, and in some cases it's very, very far from each other. So that's one of the issues that, in fact, whilst we know quite a lot about this, what exactly is happening, but the point being is it causes all sorts of complexities in relation to the variations. What we spoke about, the Danjan limit, the sun-moon separation, all those things are affected by this. And also remember that if we are going to, so this is the horizontal plane, if we were to look at the sun as a point, the Earth's orbit is actually a linear plane. So if this was the sun and we were looking towards it in this direction, this was the sun here, the Earth is actually a linear plane. But the moon is actually in a three-dimensional plane. So it is not only in a horizontal circular location like orbit like this, it's actually also in a plane, in an XYZ plane that actually goes around in like that as well. So all of these things, this issue here, the distances, and this over here, have all to do with the complexity in relation to the ability for us to tell whether the crescent can be sighted or not. And obviously that is because all of these things interact in one way or the other very fluidly and dynamically every moment with the variations and the variables we have just spoken about. And we have spoken about the atmosphere, specifically the aspects surrounding the clouds and the haze that actually can be in the atmosphere. The horizon temperature is also an important aspect, which in fact affects how we see things through telescopes. And I want to quickly look at that issue as well to understand how telescopes can be in fact problematic in the early parts of crescent sighting. And our eyes are in fact somewhat better in adjusting to certain things surrounding particularly what is referred to as the horizon temperature. So let's say this is the horizon here, and we would be standing, say for example, here, and the moon is somewhere here. When we look from here to the moon, it is not just a monolithic view or observation through a vacuum. In fact, what happens is we have these patches of all different kinds of densities of air, and this is just a very rough diagram of what actually is happening. And you will experience this when you're traveling with in an aeroplane. When you travel through an aeroplane in the sky, you'll come through these areas over here, and in fact you will experience the plane to drop. And this what is normally referred to as air pockets. And this issue is a very important matter as to how our visibility is affected when we look through this amazing amount of atmosphere towards the crescent, which is so far away in reality. And this can be affected based on different things on the ground. So you can imagine you looking through, you go to a park or to an ocean, and you're looking towards the horizon and looking for the crescent. So you could actually have in one location some grass, and then over the grass there can be an area of sea or something like that. So this is the sea. And you can also have, say for example, areas of roads, and this road over here can actually heat completely differently to, say for example, how the ocean heats or how the grass actually heats. And these causes different kinds of pockets of air in the atmosphere that you're looking through. And so the reality is that you are actually looking through, and there is an amount of refraction happening in this pockets of air. And this refraction, your eye is actually adjusting in microseconds to actually look towards the moon, towards the crescent. And so when very fine line of when there is a very fine line of a crescent, let me just rub this off here for the moment. When there is a very fine line of a crescent formed over here, you can imagine how difficult it would be when this is so fine a line in this atmosphere that you're looking through with all of this refraction actually happening, and you're trying to look for the crescent. In fact, a good example of this refractive factor is how we see the stars. So you'll see stars glittering in the space out there, and it basically having this kind of twinkling, and the twinkling is because of you looking into the space, and the different densities of the air is creating the refraction, and the light that comes to your eye is slowing and speeding and slowing and speeding, and therefore you see the twinkle. And now, if you can imagine that with the crescent, remember it's a very fine line in a reasonably bright sky after sunset, and it is impossible. It is highly difficult to then see a very young crescent if it in fact is present. So the point ultimately being is that the horizon temperature can play havoc in how we are able to sight the crescent at any one particular time, to the extent where if you were to do the same thing, the same kind of sighting with a telescope, at the earliest time of the crescent, not later, not when the crescent has particularly properly been formed, and after the crescent when we're looking at into the waxing gibbon and the half moon, and obviously at that point of time the telescope is a far superior element for us to look towards the moon. But at the earliest part of the crescent, when you are looking through these pockets of air, the telescope is unable to actually focus appropriately, and sometimes you will hear, if you've ever used a telescope will sort of go crazy a little bit for a few seconds, meaning that it's trying to focus but it can't focus. Why? Because of these different densities of air in front of you. However, mashallah, our eye does a far better job in instantaneously refocusing despite the pockets of air, for us to get this very clear and unwavering and non-twinkling view that we have on our earth. Of course, when we look towards the sky, towards the space, the twinkling is seen because the distance is greater and we're looking through a great amount of atmosphere before we look towards into the space and the light that actually comes from there. But in our own particular distances, in normal civil distances, the twinkling is not there because our eye is able to very quickly adapt to the situation it finds itself in. So these limitations, these factors which are natural, are something which we know about. Some things we can calculate, some things we actually have no ability to calculate. Can you imagine calculating the different surfaces that you're looking over at any one particular time? Your lawn, the trees, water, roadways, etc. These all have different implications to the atmosphere. We can't calculate this. So the different craters, by the way, the information we have, the calculative information we have in predicting the crescent, it assumes the moon to be a spherical shape without these mountains and craters on it. There's no real adjustment that actually is made for that, and even if an adjustment was to be made, it is entirely theoretical and very, very approximate. So we have many things we know about the moon. There are many things we in fact don't know about the moon, and even to the fact that in the things that we do know, we are unable to make appropriate adjustments for them in order to come to a precise and certain prediction and calculation of the crescent to be formed. But we do have a beneficial use. There are many beneficial uses of the scientific data. There is no doubt that in fact scientific data is very helpful for us in order to have a more accurate ability to cite the crescent. And some of those particular ones is firstly that the scientific data provides us with accurate sighting guides. We improve our sighting possibilities. It reduces mistakes when identifying the crescent. Sometimes there can be in fact what is called a flare, which is made by aeroplanes because of their fuel. And I have personally experienced this. I do moon sighting on a monthly basis. I have been sighting the moon for approximately 20 years, and I have been with people who actually have seen flares of the fuel and thinking in fact a crescent was present. And a bit later on in our program, I will share with you some photographs about these different kinds of formations in the sky, and people in fact can make a mistake about that. So sighting data, scientific data, helps us improving our sighting possibilities and reducing the mistakes in identifying the crescent itself. It also helps us to negate the incorrect claims of sighting. And remember, this is a very important point. We spoke about this in detail in lesson 1. The fiqh allows us to use data as evidence, as Imam Shafi'i himself mentions, as well as Imam Subki, in order to apply that when we know that the moon cannot be sighted, then any claim that in fact is made would be incorrect, and the data as evidence will in fact take precedence. And remember that the important part that the scientific data plays here in this regard is more, and probably exclusively, in the negation of claims, not in the affirmation, because the affirmation can only come by sighting. right? I'll just repeat that so people can understand that, inshallah. And any questions, as I have mentioned before, please do ask for clarification. That the scientific data allows us to negate incorrect claims. The scientific data cannot be used to affirm that in fact the crescent exists because of the errors in the possibilities of whether the moon in fact has existed or not. So we know in certain instances about the moon that it's impossible to sight the moon, and the data in this particular section or the stage of the crescent is absolutely important. That when it is impossible to sight the moon, for example, the moon has already set. This is an important scientific data that when somebody claims to sight the moon, that this claim would have to be rejected. We also know that in fact there is a possibility of sighting the moon. And when there is a possibility of sighting the moon, it is without a doubt that the person's witness, the testimony of a person, will override the data. Why? Because the data is inconclusive and the human being will have to be given precedence in this regard. And thirdly, we in fact know that in fact there are certain times when we know the moon definitely can be sighted. And therefore, when somebody makes a claim, remember it still has to be sighted. The fiqh, the sharia requires us to actually establish the sabab of the Ramadan, of the Eid, of the Hajj, etc. on the basis of sighting the crescent. So even if the certainty exists on the basis of scientific data, somebody still has to cite it. But the point is, when that claim is made, say for example on a reasonably partly cloudy day, when the claim is made, and because the certainty of the crescent is without a doubt, then that kind of claim will definitely be, that kind of testimony will without a doubt be accepted. So scientific data allows us to know when to use the data appropriately and when the data is completely useless. And in fact, for your information, on a monthly basis, most of the months are actually in the so-called possibility stage of the crescent, and therefore the sighting and the witnessing becomes a very important part of establishing the lunar month. We also are able to have a coherent and collaborative decision-making process. We can actually have a better regional reliability. So if you actually say, for example, in North America, then people will be making claims of sighting from all parts of America. But because you have scientific data in front of you, you're able to correlate and also compare data based on the different regions that are within the boundaries of acceptable collaboration. In other words, it's not about global sighting, but it's about regional sighting, which in fact is the next topic about the permissibility or the acceptability of local or regional sighting as opposed to the idea of global sighting. Also, because you are collaborating and having a coherent collaboration for decision making, it is easier and more acceptable and as well as more accurate in your decision making process. And I will show you a chart in a minute that I use here in Australia, as we actually are a part of a board called the Australian National Crescent Sighting Coordination Center, where we utilize a proper system, a methodological system based on fiqh and the scientific data to in fact assess any sighting claim based on a collaborative approach in the entire nation of Australia. We also have a better ability to keep records. The record keeping of the moon sighting based on past sighting, the current sighting, and the future possibilities are very important set of data to reconcile information. In fact, it helps you to minimize to the extent of completely eliminating the month-to-month error that can actually creep in because of unacceptable or sometimes mistaken information that in fact can come, whether it might be calculation or via sighting. So here is the chart that we use here in Australia, and we break down the crescent into 3 stages. So how we use this here in Australia, and something in fact which is generally accepted in the different parts of the world where physical and naked eye sighting is done as part of the establishment of each month, but at the same time utilizing scientific data, which is factual information, in order to minimize as well as eliminate errors and possible incorrect sightings, is because this is based on the fiqh of Allah subhanahu wa ta'ala's sharia, as well as the signs that Allah subhanahu wa ta'ala has given us in order to utilize them as scientific data to be able to know what to do. So generally speaking, we can say that the crescent actually goes through 3 stages. This is not the phases of the moon in its entirety, but only the crescent itself. And if the crescent is in the first stage of its development, in other words, its lunar age is less than 15 hours, its lunar altitude, in other words, how high it is from the horizon, of less than 5 degrees, and if the lag time, in other words, the difference between sunset time and the moonset time, when does the sun set and when does the moon set? If this difference is less than 48 minutes, and if what is called lunar elongation, essentially what is about sun and moon separation, is less than 12 degrees, then the sighting possibility is a definite no. In other words, somebody can claim to have sighted at this point of time, but it is highly possible, if not certain, that in fact the person in fact has seen something which is in fact not the crescent. And the acceptable decision for such a claim to be made is that the crescent in fact has not been sighted, on the basis that the evidences are not only stronger but factually correct over the claim of the witnessing of the crescent. Similarly, what we use is what you call the stage 2. So we've got these 3 stages. The second stage is where most of the months in fact lie. And so this probability of sighting is something we also need to take into account. And generally speaking, the lunar age, the age of the moon, will be about 18 hours and greater. The altitude, how high the moon is in the horizon, of around about 5 to 7 degrees, and the lag time between sunset and moonsight is 40 to 48 minutes or greater than that, and the sun and moon separation is greater than 9 degrees and around about 12 degrees. And in this situation, the sighting is definitely possible. It is probable. And the low probability, whenever there is a low probability, because remember that all of these things have to come together in a very complex way, and we can tell when there is a low probability of sighting and when there's a high probability of sighting. And when the phases are in the low probability, then we require a multiple sighting of the crescent, as per many of the fiqh documents which tell us from the classical times about multiple sightings. And if the phase is at the higher probability level, then simply the claim of sighting is accepted. Why? Because the witness in this situation will hold a greater priority over the data. Therefore, the sighting of the person and his claim of sighting will be accepted. And if the crescent falls in the stage 3 phase of its formation, the crescent will be greater than 21 hours, its lunar altitude will always be greater than 5 degrees, its lag time will always be greater than 48 minutes, and the sun-moon separation will be greater than 12 degrees, and the sighting possibility is a definite yes. And any sighting that is made in this time, and a claim made that people have sighted the moon, then you don't have to rely on evidences at all, because the testimony of such a person will be taken, because the moon is definitely sightable, and therefore the testimony of the person is accepted without fail. So that is how, by combining the fiqh and understanding why that fiqh is present through the signs of Allah subhanahu wa ta'ala, as we would know what we would call scientific data, you can combine both of those to be able to make highly accurate decisions as a community. And so I encourage all communities to in fact have a knowledge-based community organization that helps in deciphering through, analyzing through, and assessing the different kinds of claims that may come at any one point of time regarding the sighting of the lunar crescent. And that completes our session 2 of the discussions, alhamdulillah. And to sum it up, we have been discussing specifically about the scientific side of the sighting of the crescent. In other words, the reality, the natural occurrence. What are some of the things that we know about the natural occurrence of the crescent, as well as those things which are limitations because of the nature in the visibility of the crescent itself, and how the fiqh and the science can work together to provide highly accurate information on a monthly basis for our crescent sighting. Inshallah, that has been beneficial to you. And in session 3, we will be speaking about the controversial issues surrounding local sighting and global sighting, and also contextualizing some historical information to understand how the matters of geographical limits can in fact affect this idea that Muslims sometimes hold about unified sighting at a global scale. And inshallah, the program for session 2 was beneficial for you to understand the scientific side of the world, the science behind crescent sighting and lunar astronomy, in conjunction with the fiqh of the Sharia. And may Allah subhanahu wa ta'ala give us a better understanding of our deen. Jazakallahu khairan wa jazallahu anna sayyidina Muhammadan sallallahu alayhi wa sallam ma huwa ahlu. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Subhana rabbika rabbil izzati amma yasifun wa salamun al mursalin walhamdulillahi rabbil alamin.